It's actually still, yeah, we've got time to do this. And we'll finish up next time. What if this, instead of adding x to 1, I'm going to write the world's simplest and dumbest recursive function. Okay? No base case. If you ever call this, it will recurse infinitely. Right? I just want to use it to illustrate a point. So f is a function that takes a parameter, and regardless of what you call it with, let's just make it interesting. It just keeps calling itself over and over with that same parameter. All right? You'll see where I'm going with this in a minute. And then let's call that with a value. Okay? So let's actually try this in this interpreter. And you guys are going, no, don't do it. It's going to be Stack Overflow. No, actually, it won't. It's going to do something else, which is going to be seem kind of weird. Undefined variable f.
Can't see it.
Right? What went wrong?
Are we supposed to be seeing something?
Sorry? Oh, I am so sorry. Thank you.
We're in the process of finding that, so it's not
So forgive me when I switch back and forth. I wish they put the whiteboard on the screen on one side and give me more whiteboard space, but anyway. Sorry, more contiguous whiteboard space. All right, so what I did is I typed in, let's run this same example, and what happens is it says undefined variable. Okay. So what went wrong? Why can't it see f? Right, by the way, which variable reference is it complaining about? Yeah, inside this one is fine because that's clearly in scope. This one, when it actually calls that and gets to that point, that's the one that fails. So why is it failing? Yeah.
So you guys are computing the lambda for.
Yeah, think about the process. And we'll go back to the diagram in just a moment. But it's going to create this function anonymously first, and that's going to remember the current environment that we're in. Right? Then we give a name to it. So presumably f isn't defined in that environment in this example. Then we're going to create a new environment that binds f to this anonymous function, and then we'll call it here. So if you think back to the process we had a moment ago, this is fine. This will be able to actually see this one. This is the body of the width, so obviously it sees the f here. But when it goes to recurse, when we actually call this function, which environment is it going to extend? Which environment under static scoping does it always extend?
Empty?
Yeah, well, the environment of the caller, or sorry, the point was, sorry, not the caller, but the point was created, in which case, yeah, in this one, it's the empty environment. It's not going to look in this environment where f is actually defined. Okay? Which is why it turns out the right answer to what went wrong is indeed can't see it, which is what I thought you were saying when you were pointing out the board. So you were pointing out my mistake this way. You actually were answering the question entirely. So I'll show you the code fix for this next time. I want to think about this example. So you have a width. This is lambda. This is calling f0. So this part, let me get rid of the red stuff here. So the same kind of thing happens. This is an empty environment. This one's binding f to a closure, but now the function is The body is different. It's a recursive reference. But this closure still is remembering the empty environment because that's where it was created. And so when I go to actually call this, so I make the call to F0, just wrap this up. What's going to happen is, the next step is the key one. I'm going to create a new environment that binds the formal parameter x, the actual parameter 0. Right, this was f of x. Right? So, and in this environment, I'm going to evaluate f of x. Okay? So I'm going to eval that. So I go to, by the way, when I evaluate x, sure, I find it. Go to evaluate f, I look here, not here. Go to the parent environment, not there. In fact, nothing's there, so undefined variable. In other words, you can't make anonymous recursive functions because how is it then going to call itself? Right? By the way, there is a gotcha. There is actually a workaround with that, with a weird thing called the Y Combinator. We can go into next time. The key thing is to make recursion work. You don't have the closure extend this environment. You have the closure. Remember the environment in which the function's own name is being defined. So notice this environment says f is this closure, and the environment for that closure is not the environment which is created. It's the environment that actually where its own name is seen. That has to happen to make recursion work. I'll show you that one-line code change next time, but I want you to understand that what we've built so far can't do recursion, and you have to do some extra work.